AB is parallel to DC. And then what else? Perfect, angle D. Okay, and then the first reason's obviously going to be given. Where else can I fill in something that I already know right off the bat? Perfect. So I know I need to prove BC is congruent to DA. So that is going to be number 5. I'm going to put that down here. BC is congruent to DA. And now I'm going to start at the beginning and I'm going to fill in the given information. When you have a proof, the picture is there to help you. A lot of people are trying to do these today without adding anything to the picture. And they're like, I don't even know what's happening. So if I know AB is parallel to DC, that means that this line is parallel to this line. The reason why they're telling me it's parallel is because we're going to have to bring in parallel lines cut by a transversal. If I cover up these little side lengths right here, you have parallel lines cut by a transversal right there. They're just closing them in to actually make 2 triangles. I'm going to add in angle B is congruent to angle D. So I'm going to add in my angle marks because that information is given. Now, if I look, I have angle 1 is congruent to angle 2. How would I know that this angle right here and this angle right here are congruent? Are they corresponding angles? Are they alternate exterior angles? Are they alternate interior angles? Are they vertical angles? Take a second, think about it. This is kind of applying triangles and what we learned about in chapter 3. Go on. Alternate interior angles. So if you look, if these are just 2 parallel lines, if I actually cut these off a little bit, they're on opposite sides of the transversal. They are both acute. So these are alternate interior angles. The next thing I know, I'm going to add into my picture. Segment AC is congruent to segment AC. So I'm going to put in a line because it's saying a segment is congruent to a segment. So what we talked about yesterday is going to be this property. How or why can I say segment AC is congruent to itself? Would it be vertical angles theorem that we talked about yesterday, or would it be reflexive property that we talked about yesterday? Reflexive. So this is reflexive. So whenever I have 2 triangles and it's saying they share a common side, I'm sharing a side. AC is congruent to itself. That's the reflexive property. That's what we talked about yesterday. And now notice I have a triangle is congruent to a triangle. This is where these 5 theorems, AAS, hypotenuse, leg, side, 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 all that jazz is going to come into play. So if I'm saying ABC is congruent to triangle CDA, by what congruence theorem could I say? If I cover up one of these triangles, what do I got? AAS. So AAS is what I have because the side is not between the angles. So this would be angle, angle, side. The last thing that they're saying is because I know these triangles are congruent, I can then conclude that BC is congruent to DA because of what we talked about on Monday. We talked about corresponding parts of congruent triangles are congruent. So basically, once I know the triangles are congruent, everything else in them is also congruent. What's up? There is, I can tell you exactly how many proofs are on there. Let's see. They give me this like cute little document like this. And then it literally says like, this isn't the problems. It's literally just like, given a diagram, select the theorem to justify congruence. Like, what does that even mean? I know what it means. You don't know what it means. Select the correct degree measurement of the angles created by a transversal. But basically there is one. Because they are parallel lines cut by a transversal. Hold on. 1. I think there's 2, 3. If I like really look at this, I can count them up. But so far I'm seeing 3. Okay. Yeah. Yeah, so there's not a lot of proofs. That's why we don't do them all the time. We kind of throw them in here, throw them in there. They should be hopefully kind of self-explanatory while you're filling them in. Go to class. No. Bye. Yeah. I don't know exactly. I think it's 15%. It's the same as every other class. So it's, well, I don't know what it is. I think it's 15. I want to say 15 if I'm guessing right off the top of my head. I know it's not 10, it's more than 10. It may be 15, max 20. It's either 15 or 20. Okay, so let's do number 2. Take a second, fill in the first step, fill in the last step, fill in what you can. I don't understand. So the first, okay, try. Fill in the first, fill in the last, add the markings to the picture that you know are given. We'll talk about it. So, is this parallel line with parallel? Use the parallel. It's universal. This and this, the stuff that we did right here. They're alternate materials, like 2 and 8. We're jumping over the transversal, they're congruent to each other. So not only is it triangle, they also parallel lines cut by a transversal. If I take on the other 2 entities, if I see parallel lines and transversal, they're also uses of things. They're not all the same. That's the thing about proofs. It's like you gotta like work with what you know. You're gonna have a word bank. You're gonna have a drop down. You're gonna have something. You're not just pulling these out of thin air. Okay. And it's kind of like common sense, like match the words that you're talking about to something else that they're talking about. You're not going to just start talking about something random. Okay, so far this is at least what you should have. You should have been able to put the first stuff in the given, the last stuff in the prove, because that's what you're trying to get to. And then we're going to add what we can to our picture. So QK is a side. It's congruent to QA. So I'm going to add a side mark, and then it says QB bisects angle KQA. Does anybody remember what bisecting means? Bailey, you don't sit there. You give that to Aaron too. Yep. Okay. Does anybody remember what the word bisects mean? It splits it in half. So QB bisects KQA, meaning it's split in half perfectly. So because I know that, I can say that this angle and this angle are congruent to each other because it's an angle bisector. The number 2, I'm talking about definition of an angle bisector. So what do I know if it's an angle bisector? What do you think I'm going to put? Huh? QB? No. QB is the angle bisector, but what is it actually creating? The angles. It's creating congruent angles. So we're going to say angle 1 is congruent to angle 2. The reason why is because it's an angle bisector, it's splitting those angles in half. It's making them congruent to each other. Angle 1 is congruent to angle 2. Because there's numbers here, we don't have to use letters. We could use letters. We could say KQB is congruent to AQB, or you can use the numbers. Okay. Reflexive property is what you're talking about. Reflexive property is a side that they share. So what would I put there? Which side do they share? Somebody mumbled it, I think. QB. So I could say BQ or QB, doesn't matter. But QB is congruent to QB. The reason why is because they are reflexive. They're sharing the side. So I'm going to add that into my picture as well. Put my 2 little lines. The next thing is a triangle. I'm saying a triangle is congruent to another triangle. They put the first 3 letters. It says KBQ. So what letter has to go first in the second triangle? A, and then B, and then Q. Because of what congruence property can I actually say the triangles are congruent? not reflexive. Which of these 5 theorems can I say? No, not ASA. Huh? If I cover up one of these triangles, SAS, SAS, because I have a side, I have an angle, and I have a side. Since I now know all the triangles are congruent to each other, then I can add in that last part, basically saying KB I know is congruent to BA. The reason why is because corresponding parts of congruent triangles are congruent, which is CPC2C, which is what we talked about on Monday. When you know a piece is congruent to another piece, you can set them equal to each other. What's up? So because we said that this part is like, we said KB is congruent to AB after the triangle is congruent. Like if I take off these sides that I just drew in, you don't have to erase this, but if I like take these off, I have to use side angle side. I can't jump across nothing. So I can't say side A or ASS because I can't cuss. So I can only use the sides at that point. I would not add in this information until the very end. Okay. So be careful with that because yes, you're trying to prove that, but I would not use that. I would not add that to the very last step. So you probably already had those marked because you knew that they were congruent because that's what you were trying to prove. Yeah. So don't do that until then. Okay. So try to set up number 3, fill in what you can. This means something else. This will upside down to do it. Yeah. So one minute, that's literally what perpendicular is. Oh. Yeah. Congruent part is congruent triangle, or corresponding part is congruent triangles are congruent. Yeah, it's like if there's something after you're stating that triangles are congruent to each other, then it's going to be this. But normally it's self actually. Like your profit. Yeah. Yep. He's the bottom of the values. And looks probably wait just moment. Yes. So going order. Okay. Start from the bottom. Start from number 1. Breathe off. Try to figure out what that missing blank is after they talk about perpendicular lines. Perpendicular means something very specific. So for number 1, it's obnoxious. It's very long, but I'm going to add in all of this. BD, this upside down capital T. If you're like, what the heck is this? Why is it upside down? That means perpendicular. BD is also perpendicular to DE. AB is congruent to DE. So, and then you also can put this down here. I'm trying to prove that this is congruent to this. Okay. So if it is perpendicular, perpendicular means that it makes what degree angle? 90. I'm going to add that to my picture. So since BD is perpendicular to AB, that means this is a 90-degree angle. What's up? No. BD is also perpendicular to DE, so I'm going to add a 90-degree angle. I also know AB, segment AB is congruent to segment DE. So I know this so far based on what's given. Oops, sorry. If I look the next part, ooh, what does number one's reason? Given, easy peasy. So this is given. Number two, even though you don't have to fill in a blank, people are skipping this because they're like, I don't have to fill in a blank. I don't have to read that. It's giving you a piece of information you should add to your picture. It says angle B and angle D are right angles. Definition of perpendicular lines, because perpendicular lines are perpendicular lines. They create 90 degrees. Okay, I guess I don't need to fill in anything because I already did that. Angle B is congruent to angle D. All blank angles are congruent. What do you think would have to go there? Right. Because all right angles are congruent. Angle 1 is congruent to angle 2. They're telling me these two angles are congruent. How or what theorem could I use? Yes, what did you say? Vertical. So put vertical angles. And then triangle ABC is congruent to a specific triangle. If I say A first, what has to go first? No. Did you say, what'd you say? Oh, I thought you said D. I was like, what? E. Okay. What has to go if I say D next? D, and then the last one, C. Okay. And then I have to pick, because it says a triangle is congruent to a triangle, this is when you use the 5 theorems. So which congruency theorem would say, no, it's not HL. HL literally stands for hypotenuse leg. Do I know the hypotenuses are congruent to each other? What? No, I don't. I don't have a dash. I said, you need to know the hypotenuses are congruent to use hypotenuse leg. Do you know the hypotenuse is congruent to the other hypotenuse? No, I don't have any markings. That doesn't mean anything just because it's perpendicular. It's AAS. You know, 1 is congruent to 2. You know that these are both right angles. They're congruent to each other because all right angles are congruent to each other. And you have one side. You cannot use HL. Everybody was yesterday, I'm pretty sure, was like, when would you use something else besides HL for a right triangle? This is like that random 3% of the time that you would not use HL on a right triangle. When in doubt, go with HL though. What's up?
It's fast.
Because you can't jump over this. Like if it was fast, you would know that another side is congruent. Because you need 2 sides. You don't know 2 sides are congruent. A, E.
Sorry, AB. Like the AB side. They both have tick marks.
AB is congruent to DE. This doesn't have a tick mark. BC doesn't have a tick mark. BC has an angle right here. Yeah, it's a little angle. It's a little baby angle. And then once I know that the triangles are congruent to each other, that's whenever sometimes, not on your classwork, then I could say angle A is congruent to angle E because of corresponding parts of congruent triangles are congruent. Okay. No. So I'm about to show you on your classwork. That's why we're kind of doing 2 different sheets, because I wanted to make sure you had like an example of where ends in congruent parts of congruent triangles are congruent or whatever. But